Good morning, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about intersymbol interference, that is ISI. Intersymbol interference in digital data is represented by electric pulse communication channel, which is always band limited. When the channel bandwidth is greater than the bandwidth of the pulse, spreading of pulse is very less. But when channel bandwidth is close to signal bandwidth, we transmit digital data which demands more bandwidth, which exceeds channel bandwidth. Spreading will occur and cause signal pulses to overlap. This overlapping, which we call it as the intersymbol interference. This ISI causes degradations of signal which is left uncontrolled. Then, similar to the interference caused by other sources, ISI causes degradations of signals if left uncontrolled. This problem of ISI exists strongly in telephone channels like coaxial cables and optical fibers. The main objective is to study the effect of ISI when digital data is transmitted through band limiter channel and solution to overcome the degradation of waveform by properly shaping the pulse. Then the intersymbol interference mainly deals with the raised cosine response, which means the Nyquist ISI criterion. Consecutive raised cosine pulses demonstrates the zero ISI property between the transmitted symbols at the sampling instance. At t equal to 0, the middle pulse is at its maximum and the sum of other pulses is 0. In communications, the Nyquist ISI criterion describes the conditions which, when satisfied by a communication channel, which results in no intersymbol interference or ISI. It provides a method for constructing band limited functions to overcome the effects of intersymbol interference. Then the effect of sequence of pulses transmitted through this channel is shown in the figure. The spreading of pulse is greater than the symbol duration. As a result, adjacent pulses interfere. That is, pulses gets completely smeared. Then the tail of smeared pulse enters into the adjacent symbol intervals, making it difficult to decide the actual transmitted pulse. Intersymbol interference occurs when a pulse spreads out in such a way that it interferes with adjacent pulses at the sample instant, where the data 1 of this ISI is shown here, then the data 0 of ISI is shown here. For the input data stream 101101, the channel output is the superposition of each bit's output. This is the exact ISI, that is intersymbol interference, which we get. So then the last one is the resultant channel output waveform. The ISI, which mainly affects on eye pattern, that is, the amount of ISI can be seen on oscilloscope using an eye diagram or an eye pattern, distortion, noise margin, and the extension beyond TB is ISI. Then, if the rectangular multi-level pulses are filtered improperly as they pass through a communication system, they'll spread in time and the pulse for each symbol may be smeared into adjacent time slots and cause intersymbol interference. There are three strategies for eliminating the ISI. First, to use a line code that is absolutely band limited. Then use a line code that is 0 during adjacent sample instance. Then use a filter at the receiver to undo the distortion introduced by the channel, where we call it as a raised cosine role of pulse shaping and the equalizer. Then the Nyquist first method for zero ISI, there will be no ISI and the bandwidth requirement will be minimum. That is the optimum filtering if the transmit and the receive filters are designed so that the overall transfer function is HEFF, which is equal to 1 by Fs by F by Fs into HE of t, which is equal to sine pi Fs t by pi Fst. This type of pulse will allow signaling at a baud rate of d equal to 1 by Ts, which is equal to 2b. The absolute bandwidth is b equal to Fs by 2. Then the minimum bandwidth, where the signaling rate is d equal to 1 by Ts, which is equal to 2b. Then the Nyquist first method for zero ISI is, since the pulses are not possible to create due to infinite time duration, sharp transition band in the frequency domain, and then the sync pulse shape can cause significant ISI in the presence of timing errors. Then we can seek a pulse shape that has a more gradual translation in the frequency domain, where raised cosine filter is also called as a Nyquist filter, that is represented as here, where D which is equal to Fs which is equal to 2F0. The assessment is what is mean by ISI, define I pattern, and what is mean by the Nyquist filter. Thank you.